Okay, Assalamu alaikum. Welcome to Study Guide Sheet. Video number 1. We will solve the questions from 1 to 5. So here. And let's start with the first question, which states choose the correct one, which I'm guessing it's going to come in multiple choice, but in this case, we will answer them. So here they tell us that the function of x is equal to x squared plus 10. Find the derivative of f3. What does this mean? It means that they want us to find the derivative first and then sub in for 3 for the value of x. Okay, so first step, we will find the derivative of this function. So we will use the power rule, which states that if y equals x power n, then the dx over dy will equal n times x. So we'll put the n backward and then minus 1 from the power, which will become something like this. Now, in this case, the 2 will go back, so it becomes 2x, and then 2 minus 1 will be 1, so we don't have to write it. Plus, the derivative of a constant is always 0, so the derivative of 1 is 0. The derivative of 100 million is still 0, so it doesn't matter what it is. If it's a constant, then it's always 0. Now, after we found the derivative of this function, then we will sub in for the value of 3 in the place of x, so we'll put t or 2 times 3, and this will give us 6. So this is the answer. Now, if you go to the second question, it asks us to find the derivative of the functions. Now, here they gave it us in an equation form, how to find the derivative. Now they want us to find it in a geometric form. How will we solve this question? Well, basically, we have to know first that what does a derivative do to a function? What are the actions that it performs on it? It basically drops the degree of the function by 1. So if we have, for example, x cubed, then if we take the derivative of this, it will become 3x power 2. So what happened here is, see, the power here was 3, now it became 2. If we do it again, it becomes 6x, then minus 1, so it becomes 6x power 1. So here it was, in the original function, it was power 3. Then we took the derivative, it became 2. And then we took the derivative again, and it became 1. So now we know this idea. We have to know what will happen to this function if we take the derivative of it. What is the shape it's gonna take? So if we have a linear line or equation, which is x, if we take the derivative of this, it will equal 1. So it will be a straight line. So now we found what it will look like. Let's find where this straight line will be located at in this graph. Basically, in order to do this, we must find the slope, aka the derivative. So the derivative here, if we write derivative, it means slope, okay? But we use derivative in calculus, and we use slope in algebra. Okay, so here we find that the slope here is 1. Why? It's because the rise is 1, as you see here. So from this point to this point, there was 1 rise, and from the run is basically, it went from here to here. So the rise over run is 1, hence the slope or the straight line should be located here. Sorry. Okay, now we'll do this more quickly. Again, it will be a straight line. So what is the slope of this function? We see that the rise is actually -2. So from this line to this line, it went -2. So, and the run is still 1. So here from 0 to 1 is 1, the difference. So it is -2. Hence, the straight line should be at or located at -2. Now here we have a parabola. So a parabola is basically x squared. So if you take the derivative of this, it will equal x, okay? Which means that it will be a straight line. Let's go from the stomach of the function, and where from the right hand side we see that the function is increasing. So the line from the right hand side should be increasing too, and from the left hand side it's also increasing, so it should also go down like this. Hence, this is what it should look like. Okay, now if we move to question number 3, figure gives figure gives the position of f of t of a particle at a time t, at which of the marked values of t the acceleration must be negative and positive. Basically, what is acceleration? We studied with Mr. Hayat that acceleration means double derivative. Why? Because velocity will be the derivative of speed, it's the derivative of something, and acceleration will be the double derivative of that. So this is just a single derivative, and acceleration, excuse my spelling, is the double derivative. Okay, what is the double derivative? It basically asks us where is the point. Is it concaving up, is it increasing, or is it decreasing, so concaving down? And here they ask us in which of these 2 points, okay, at which of the marked values of t the acceleration must be negative and positive. Okay, so here at t1 we see that it's located in a location where the double derivative is increasing, it's concaving up. Same with t2, it's concaving up. We see here it's increasing, it's up. While with t3 and t4 we see them actually concaving down. Okay, what about t5? So for t5, some students may make a mistake and say that it's decreasing, right? It's like this and it's decreasing. Here's t5. But no, you're actually wrong. It's actually concaving up. Why? It's because the natural behavior of this function will actually increase after then. It will go like this. So t5 shall be increasing or concaving up. Hence, what does this mean? Our answer must be, we said that t1 and t2 and t5 will be concaving up. So for positive, we say t1, t2, and t5. And for negative, we said t3 and t4. So negative, t3, and t4. Moving to question number 4. At which values of x, at which values of x at which the function is and not differentiable? Basically, here they ask us each of these x-axis or these points, is it differentiable or is it not? Now, let's first answer what does differentiable means. Differentiability basically means can you find the derivative of this function, the process of finding the derivative of this function. If you can do it, then it is differentiable. If you cannot find the derivative of a function at a certain point, then it is not differentiable. Now, for differentiability, we have 3 rules. First one should be no sharp corners. Okay, so if we find any sharp corners, like this, for example, we see here that it's going like down, then sharp up, then it shall not be differentiable. 2, there shouldn't be vertical tangents. What does this mean? It means no vertical asymptotes. Okay. Number 3, it shall be continuous. Okay. So, after we revise these 3 rules, let's go to this function. Let's first find where the function is not differentiable. We can see that 4 is clearly not differentiable because at point 4 we see a sharp corner, hence x equals 4. And if we go to x equals 2, we see that there's a vertical tangent line, which means that 2 is also the point in which x equals 2 is also non-differentiable, etc. Now for the rest of the points, they are differentiable. So we have 1, 3, 5, and 6 are differentiable. Now to the last question, find the derivative of the given functions. Now they gave us 2 questions. And in order to solve these questions, we must first revise the power rule again. So we said y equals x power n. Then the derivative of this function will equal to, so we write dy, okay, let's actually write f of x this time. So it will become f prime x shall equal, so we put the n down, so it becomes n times x, and then minus 1 from the power, so it becomes n minus 1. So if we go here, and this we don't like having the function in this form, because in the rule it's not in the form of a fraction, so we will just flip it, and with flipping the fraction we shall flip the the sign of the power. Okay, so if we flip this function it becomes x squared, but because we flipped it, it shall be negative x power negative 2. And now we can apply the power rule. So we put the 2 down, it becomes negative 2 times x minus 1 from negative 2, so it becomes negative 3. Again, we don't like having negatives in powers, so we will just flip it again. So x power negative 3 becomes 1 over x cubed, and then times negative 2, this, which is equal to negative 2 basically times 1. So this is the answer for the first question. We'll do the same thing for the second question. So let's actually first separate the two. So let's write 2 times 1 over x cubed. Again, let's flip it, so it becomes 2 times x power negative 3. Okay, so we flip the fraction and with the sign along with it. Now we shall apply the power rule. So we put the 3 or negative 3 down, becomes 2 times negative 3 x, then negative 3 minus 1 is negative 4. So 2 times negative 3 is negative 6x, power negative 4. Again, we don't like having negative in the power, so we write negative 6 over x power 4 positive. We just did the same step with the first question. We flipped the x and then we times it, the 1 by negative 6. And that I think, yeah, that sums it up. Thank you very much for watching, and let's move to the next 5 questions.